All right, so here in this video, we're going to do some circuits. We're going to practice a few loop analysis type circuits. In the last video, the last example video, really didn't get to any circuits because I wanted to show you a technique that could be used in doing some of these problems on when you have, at the end of the day, a system of equations, two equations with two unknowns to try to solve for whatever current you're trying to get. And if you don't want to do or don't feel like doing the substitution method or whatever other algebraic method you know of for solving those types of things, this is a more advanced technique, Cramer's rule, using matrices to be able to solve a system of equations. Now that we've seen it, I can go ahead and use it in doing these. You don't have to use it when you do your own problems or on the test. I won't mandate you use this, but likely you're going to see me sometimes using Cramer's rule to solve some of these. So I wanted you to see what that was all about. So let's take our first example. Let's say we have this circuit. So this circuit, it's got two voltage sources and it's got four resistors. And what I'd like to do is I'd like to go ahead and solve this table. 2, 3, 4, and 6. I want to find the current and voltage for each one of these resistors. Now I look at this, I see, okay, there's two voltage sources. Let me go ahead and try using loop analysis here. So in each loop, I'm going to have a current. I'm going to choose the currents to go clockwise, just arbitrarily. I'll call the current in the left loop I1 and the current in the right loop I2. Now, let's look at the left loop first. So what do we have? Current's coming in, hits the voltage source, hits the small, then the big, that's positive. So we gain 10 volts. Then the current hits the 2 ohm resistor, so it's going to lose 2 times I1. Because the voltage loss is I times R, I1 times 2. Then it hits the 3, but notice the 3 feels two different currents, so we're going to lose 3. What's the current hitting him? Well, note that I1 is going this way, whereas I2 is going that way, if we follow the paths. Because they're moving in opposite directions, we're going to subtract them. I'm on the I1 loop, so I1 will be the positive one. I1 minus I2. So he's done. I continue along, and then I get back to the beginning, so I get to 0. There's my left loop equation. Let me go ahead and write it out. Distribute everything. 10 minus 2I1 minus 3I1 plus 3I2 equals 0. And then I know eventually, because there's two unknowns in this equation, I'm going to have a system of equations. So let me write this in standard form. Standard form means all the I stuff goes on the left and the number goes on the right. Okay, so minus 2I1 minus 3I1 is minus 5I1. And then plus 3I2 equals minus 10. So there's his equation. What about the next equation? Well, let's look at the right loop. Following I2, we hit the voltage source at the top. It hits the big side, then the small side, so he's minus. So he subtracts off 5. Then he hits the 4 ohm resistor, so minus 4 times I2 is what hits him. Then he hits the 6, so minus the 6 times what current? I2 again. And then he hits the 3, so minus 3 times what current hits him? Both I1 and I2. Again, they're moving in opposite directions, so they're going to subtract. But this time, I'm using I2's equation, so I2 will be the positive guy. I2 minus I1. And then I'm back at the beginning, so set it equal to 0. All right, now, let me clean it up again. We have minus 5, minus 4I2, minus 6I2, minus 3I2, plus 3I1 equals 0. Standard form as usual, all the i's on the left, the number on the right. And let me again start with I1 first and then I2 second. So we have 3I1. And in I2 we have negative 4 minus 6 minus 3 is minus 13 I2 equals 5. All right, and again I'm stuck. I've simplified it as much as I can. It's got two unknowns in this equation, so I can't solve it by itself. But now I see I have two equations with two unknowns. So at this point, the physics is done. I've done all the physics I can. Everything else from here on out is math. I've set up my equations. I've gotten them into standard form. All that's left is to solve these things. So let me go ahead and rewrite this just to give me some room to do it. So I'm going to erase some stuff. We have the first equation, minus 5I1 plus 3I2 equals negative 10. And the second equation is 3I1 minus 13I2 equals 5. So now I can erase all this other stuff, and I can start working from here. What do I have? Two equations, two unknowns. I'm going to use Cramer's rule. Using Cramer's rule, I need three matrices. What are they? The W, the X, and the Y. Not X and Y. What am I doing? That's my general thing. In this case, it's the W, it's the I1 matrix, and it's the I2 matrix. Those are my two unknowns, I1 and I2. So those are the matrices I need. What's the W matrix? Again, the W matrix is the one that's the coefficients on the unknowns. So minus 5, 3, 3, negative 13. What's the I1 matrix? It's the same as the W, except instead of the I1 stuff, I have the answers, minus 10 and 5. And what's I2? I2 is the same as the W, except instead of the I2 stuff, I have the answers. So there, we now have our matrices. Next step, I want to do the determinants. So the determinant of W is going to be, well, negative 5 times negative 13. That's positive 63. Well, let me go ahead and write it out just to make it a little more clear. We have negative 5 times negative 13 minus 3 times 3. So negative 5 times negative 13, that's 63, minus 9, which is 52. I1. I1's determinant, we have negative 10 times negative 13 minus 5 times 3. So 130 minus 15 which is 115. And lastly, the I2 matrix, which is negative 5 times 5 minus 3 times negative 10, negative 25 plus 30, which is 5. All right. Now we have our determinants. We could get our I1 and our I2. I'll do this in green. I1 is the determinant of I1 over the determinant of W, which is 115 over 52. Let me go ahead and get an answer out of it. 115 over 52 gives me 2.21. And then I2, same thing can be done. I2 is the determinant of I2 over the determinant of W. 5 over 52. Which gives me 0.096. All right, good. Now, let's answer the question. The original question didn't want I1 and I2. What the original question wanted is what's the current on each resistor and what's the voltage dropped by each resistor. So how do I do this? Well, what's the current on resistor 2? Well, the only current that hits resistor 2 is I1. What is I1? 2.21. So there we go, 2.21. And then to get his V, I take his I times his R. So 4.42. Let's skip 3 for now. Let's go to 4. What current hits 4? The only current that hits 4 is I2. I2 is 0.096. What's 4 times 0.096? 0.384. All right, what about the 6? Same thing. The only thing that hits the 6 is I2, which is 0.096. Then we need his V is his I times his R, which is 0.576. Now the last one, which is the more complicated of the two, of the four. 3, resistor 3. What current hits resistor 3? Both of them hit. I1 hits him and I2 hits him. So I'm going to have to add them. However, note, they go in opposite directions, so really I have to subtract them. If they were both moving in the same direction, they would add up. But here, they're opposite, so they subtract. So I'll take I1 minus I2, 2.21 minus 0.096, which is 2.11. Now that I have his I, his V is I times R, which is 6.33. And there we go. I've now filled in my table. And so now you see how do we use Cramer's rule to be able to help us solving this. You don't have to use Cramer's rule. You could have done it by substitution. That's fine. But at the end of the day, you're still doing the same thing. You need to calculate I1 and I2. Once you have I1 and I2, then you can use them to figure out this table. All right, let's do another example. Let's take this example. All right. Here's a circuit. Again, I want to fill in this table. So let's do the same thing. Here we have a circuit. It's got two voltage sources. I'm going to choose to do loop analysis. Each loop gets its own current. Here's I1. Here's I2. All right. Let's look at the first loop. What do we have? I1, let's say it hits the 5 first, small to big, so that's positive 5. Then it hits resistor 2, so minus 2 times. What current hits resistor 2? I1 and I2 both hit. However, I1 is moving to the right, while I2 will be moving to the left, so they subtract. So it's I1 minus I2. Then he keeps going, he hits to 3, so minus 3 times. What current hits to 3? Only I1. And then we're back at the beginning. Simplifying this out, we get 5 minus 2I1 plus 2I2 minus 3I1 equals 0. And standard form gives us minus 5I1 plus 2I2 equals negative 5. Second loop, we'll do the same thing. I2 hits the 10, hits the small, then the big, so he's adding 10. Then he hits the 1, so minus 1 times. Only I2 hits him. Then he hits the 2, so minus 2 times. I2 and I1 hit him in opposite directions. I'm on the 2 loop, so I2 is first, minus I1. And then we're back at the beginning. 10 minus I2 minus 2I2 plus 2I1 equals 0. Standard form again is 2I1 minus 3I2 equals minus 10. Remember, when you do standard form, you want to have the same variables in the same order. So I1, then I2. Even though we're on the I2 loop equation, don't make I2 first. I1 is still first. All right. So now we have our two equations. Let me go ahead and just rewrite the second equation under the other one so it's easier to see. 2I1 minus 3I2 equals minus 10. There we go. Again, I'll use Cramer's rule. I need my three matrices, W, X, and Y. What's the W? It's all the coefficients. Minus 5, 2, 2, and minus 3. What's the X? The Y stays the same, 2, minus 3, but the X is now the answers, minus 5, minus 10. What about the Y? Same as the W for X, minus 5 and 2. But now the Y column becomes the answers, minus 5 and minus 10. All right. Determinant time. Determinant of W is minus 5 times minus 3 minus 2 times 2, which is 15 minus 4, which is 11. What about for X? X's determinant is minus 5 times minus 3 minus negative 10 times 2, which is 15 plus 20, which is 35. One more to go. The Y matrix, determinant of Y, is minus 5 times minus 10 minus 2 times negative 5, which is 50, plus 10, which is 60. All right, all the hard work's done. Now we get our answers. Yeah, I'm sorry, I'm still doing it. X and Y should be I1 and I2. I1, I2. I'm just so used to X and Y. I1 stuff, I2 stuff. All right. So, I1 is determinant of I1 over determinant W. So that's 35 over 11, which, just to get the decimal answer, 35 over 11 gives me 3.18. I2 is the I2 determinant over the W determinant, which is 60 over 11, which gives me 5.45. Now that I have these, I can go ahead and fill in my table. Let's look at the first one. Resistor 1, only I2 hits him, so 5.45. His V is I times R. 1 times 5.45 is 5.45. 2. What hits 2? I1 and I2 together. They're moving in opposite directions, so I'm going to subtract them. 5.45 minus 3.18 gives me 2.27. 2.27 times 2 gives me 4.54 for his V. Last 3. What hits 3? Only I1 hits 3. I1 is 3.18. 3.18 times 3 gives me 9.54. And I've got my answer. And so you see, again, given a loop analysis problem, the physics stuff is setting up the equations. Looking at the loops, take a current in each loop, set up the equation for that loop. It's an equation of voltages. When you have a voltage source, you're either plus that voltage or minus that voltage, depending if you're hitting small then big, that's plus. If you hit big then small, that's subtracting, it's minus. When you hit a resistor, you're subtracting, and the voltage is I times R. So whatever I hits that R times whatever the R is. And so now you have a whole equation with a bunch of V's. Of course, the V's are really I times R's. And you set it equal to 0. Do the same for each loop. You now have a whole bunch of equations, one for each loop. Simplify them down to standard form, which will be blah, 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 I1 plus blah, 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 I2 equals some number. So you have now a system of equations. At this point, the math takes over, and you use whatever mathematical technique you want to solve for I1 and I2. Once you have I1 and I2, of course, you can use that information to fill in the table, because you look and you see, okay, for this particular resistor, what I hits him. I1, I2, both of them, whatever it is. Once you know that, you just take the answers from I1 and I2 and plug them in. And then to get the V's, you take the I times the R. You just multiply the row out. So I hope this is helpful. I hope it's kind of clear how to go about doing these loop analysis type problems. If you have any questions, of course, email me. I'll be happy to help however I can. But practice them. Practice them a lot. Little mistakes pop up with negative signs and things like that, so you just have to be very careful with your negatives. But as long as you're careful, the actual method is fairly easy. It's not all that complicated to do this kind of analysis. It actually is very straightforward. I find this easier than Ohm's law. Because with Ohm's law, at least then you have to figure out what's in parallel, what's in series, and things like this. Whereas here, it's pure, straightforward, cranking out the machine type of a thing. So practice them. You'll get the hang of it fairly quickly, and then we could go from there. So, until next time.